Hello out there, Rutinchi here. Um, I'm about to start a new series on the Go programming language, and uh, I've recently been inspired to up my production value. So hopefully you will notice in this video a higher production value, as well as in all future videos having a higher production value. Actual thumbnails and the like. Um, Along with this change, I'm contemplating changing the format of my tutorials as well. So in the past, I've focused on concept first, and then kind of revolving the code around the concept. I'm thinking about changing it up to where instead of I create an example application, program, whatever you want to call it, and then we discuss the concepts as they come up, as they are new. So I'm going to try that for this video. I would love your feedback in the comments down below. Please, please, please comment down below. Tell me whether you like it or you don't. Also, feel free to do the thumbs up or the thumbs down to vote. If you would rather not actually say something and just hit the thumbs up or thumbs down, please. I don't care which. I just am looking for feedback. I appreciate it. So, in the Go programming language, I will get into how to set it up later, because you can go by the instructions on the website, and that will be fine. If you're one of those who prefers to use something like Homebrew or apt-get or some other sort of package management system to install it, you might have some nuancy things depending on distribution and the like. I highly recommend DuckDuckGo for your searching needs. So we're going to start out in this example, the same with the quintessential example when starting a new language, and that is, of course, Hello World. So I've actually already typed this out because I was testing it out to make sure that Go was working properly on this computer. It's actually been a while since I've used Go on this computer, so it's always good to test your tools. So anyways, in Go, you always start your Go files by declaring what package they belong to. In this case, it is a package by the name of main. And main is actually a special package that lets us know, lets the compiler know that this is our entry point into actually executing this program. It was the entry package for this program. We then import or bring in another package that in this case is FMT or format. That's actually a built-in package that we'll get into why we're using it in a second here. But all packages start, or all files start by declaring what package they belong to, and then you can import other packages using the import, so that you can use functionality from them. Now, I said that main package it lets it know what package to start from. But the actual entry point into it is a func or function called main. And notice the lowercase m. Lowercase and uppercase in the function name actually does have significance. It determines whether a function is public or private. In this case, though, we want to make sure that this main function is private, and thus it's lowercase. We'll get more into public and private later, but just so you know. So with any function, you need to define whether it has any input and whether it has any output. In this case, we don't have any input, but we still have to put the parentheses because that's the only way that it knows that's the correct syntax for declaring a function. You have func, and then you have the function name, and then you have the parentheses to denote variables going in, or parameters, or arguments, or whatever you want to call them. And then after here, we would have the output type if we had an output, but we don't. And then you have the curly brackets to encase the code of that particular function. In this particular case, we're just doing one line, which calls into that package that we imported up here using a period. So we do package name and then period to call into that package, and call from that package the print line or print line function. And again, since we are calling a function, we're telling it that we're sending into it with these parentheses this string. It's a string of characters. So strings are basically text. There are some special strings, but generally it is your text. And so anytime you see text in a program, somewhere behind the scenes is a string of characters. So let's, I'm actually going to split this window and pull up a shell. And so with Go, there are two ways to actually run this code. First, we can do, let me show you the contents. We just have this file. So first you can do go run if you just are doing a one-off run of the file. So you do go run and then the name of your file, and you notice it printed it out, and it's still just that file there. But if we want to actually build, we can do go build, hello, and now if we look here, you see there's actually a hello executable. So if we call that executable, again we get hello world. So exactly as expected. So let's go back over here, make this full screen again. So there's hello world. Simple as that. If you're used to different, I mean, all programming languages have their little nuances and isms. Not terrible. So what if we want to do something a little more with this? Like, for instance, let's have it print out, and this time we're going to use a different print function. We're going to use printf for print format, or formatted string, and we're going to say random, and then we're going to say percent. Whenever you're in a formatted string, which is what printf takes. It's just a normal string. It just happens to have special characters in it, or could have special characters in it. And if it has those special characters, which start with the percent in this case, immediately following the percent tells it what type of variable it's actually going to inject into this formatted string. So we're going to do I for integer. And then we're going to do a /n for new line so that we get a fresh line after that. And then we're actually going to send into that 42. Got to send in a number, so let's send in 42. Let's split again. Let's split again. And bring our shell up. And at some point I'm going to make that prettier. But for now, let's just do go run. Hello. Go, and you'll notice we've got hello world, and then below that we've actually got random : and you see what almost looks like garbage, except that it's telling us, okay, we've got an integer and it's equal to 42. So it's telling us both the type and the content, but we don't really want that. What we really want is just the decimal value, the digit value. So let's try D instead. So we save that, go run. Whoop. I'm going to remove that executable so that it stops doing that. Go run. Hello. And now we have just the number. So D does percent D does just the number. Percent I does a introspection on that variable. And here's short. You can also do one super handy one. So percent %s would do a string, but you can also do percent %v. I forget exactly what that stands for, but what it does is pretty awesome. it actually shows it pretty. It tries to, as prettily as it can, print whatever the content, whatever the data in that structure is. So in this case, it's just 42. But if this was some sort of complex structure, it would actually try and print out as prettily as it could all of the different data that was inside of that structure. So that's a handy one to remember as well. So we'll leave that as V because why not? So, but 42 is not terribly random, is it? So let's go to the docs. So I've loaded up GoLang.org, and I'm going to go to packages because that's all of our built-in packages. You can also search through various things. You can go to documents to learn more about things. But I happen to know that I don't want the random inside of crypto, but I want the rand inside of math. So I'm going to go in here, and let's look at this example. Okay, so it's seeding the random. We could seed it with 42, and then it's got this list of this array of strings. Don't worry about the array, what an array is or any of that, and then it's accessing a random string from that. Well, that's some help. Let's random int in. That looks very helpful, because if we go down here and let's look at int in. So seed's pretty straightforward. Seed is just seeding it so that it is potentially less random than it would be otherwise. But int in, let's see, int in returns as an integer a non-negative pseudo-random number inside of the set, beginning with and including 0, and up to but not including n. So that input, that parameter that it takes in. So that's what that's for. That's our maximum. That's our maximum random number that it'll give us back. And then you notice after this, see, this is what's called the definition of the function. So we have func, and then we have int in, and then we have the parameters, which is just in, which is of type int or integer, and then it returns back a simple integer. So if it panics, from source, so from the random that called it, and it panics if n is less than or equal to 0. So we have to make sure that we do not put a 0 or a negative number in here, or else it will panic and crash. So let's scoot back up there. So you notice in this example we can see exactly what we need to import. So, and you actually see a different way of importing here as well. So if you don't want to keep doing import blah, you can actually start basically an import block where you can import multiple things, and in this case math rand, and we're gonna, underneath hello world, we're gonna do rand seed, and we'll put that 42 in there because 42 is an awfully special number. And we're just gonna straight up call the random number right here, and int in, and then we put into it whatever we want our max to be. So let's do 100 in this case. We can save, and let's break it up again. Sure, not exactly what I meant to do, but it'll work. Go run, not random. Hello world. All right, so we got a 5. Let's do it again. Oh, we're getting the same thing over and over again. That's no good. So maybe we should make our let's make our seed something different and see. Actually, let's see what that does too, because that might have changed it. All right, nope, it's still 5. So let's change our seed. Let's make it 420. let's see if that changes. Yep, that changes that, but I bet you money if we run it again, yep, same thing. So instead, let's seed it with time, the time. And you know what, let's go ahead and pull up the time package. We've got all we need from here. So let's go back here and to the list of packages. Go up and find, or down rather, to find time. And once it loads up, because slowness. Alright, so it looks like we can just do time now. What will time now? Let's look down here and see what time now is going to return back to us. We need to make sure that it's going to return an integer, but it's returning a time. So how can we convert this time to an integer? Let's look down here and see what has an output that might be compatible with integer. Oh, here we go. It's returning an int 64, but that works perfectly. And it's doing, okay, so, ooh, we could also do seconds. Or is there milliseconds? Nanoseconds, that would work. Let's do nanoseconds. So let's click on here just to make sure we really understand what's going on. All right, so perfect. So we're going to do time now to get the time now. Okay. And it was a function, but it didn't take anything in, but it returns a time that we are then going to call nanoseconds on another function, nanoseconds. So this is something new. So you notice it's func, and then it's got parentheses before the actual function name. Well, what that's saying is that this function can be called from something of this type. And if we were defining this function, we would actually be able to reference the time that was calling this using this t variable. So that may not make a lot of sense right now, but in future videos that'll make a lot of sense, and you'll start to understand and see some of the really cool parts of Go. But for now, just realize that in order to call this, we have to call it from a time object. Not the time package, but a time object. And luckily, that's exactly what now gives us. So time.now is actually giving us back a time object. So we're going to do nano sec. Whoop, nope, it was all lowercase. Second, was it plural? No, singular. And parentheses to call it. All right, we saved. Go run. Hello. Okay, so the error we got here, cannot use time now nanoseconds, which is of type int, as type int64. So seed is actually looking for an int64, and I would have noticed that if I had actually looked at the definition of it, which is, where'd you go? Oh no, it's back at the random. But if I had looked at it, I would have noticed that it was in 64. So what we need is, we have two options here. We can either convert this nanoseconds to int64, or we can use this first one that I found, the Unix nano, which is, I happen to know, it's the nanoseconds from the Unix time, which Unix time counts from what's called the epoch, which is an arbitrary time date that they start at 1 for. Okay, doesn't matter a whole lot, but anyways. So tell you what, we'll do that Unix nano instead. So we'll switch this function over to Unix nano, because y'all don't need to worry about casting just yet. It's kind of dangerous if you don't know exactly what you're doing. Alright, so there's random 12. Let's make sure it changes. Something different. That's something different to me. 30. Yep. Yep. Awesome. Alright, so we got truly random numbers now. And it's going to change every single time we run it. And we could actually loop over and it would give us different numbers every time then too. So, but we wouldn't need to reseed it every time. You just rerun it and the seed would have done its job already. So that's the new format. We go through an example and learn as we go. Tell me what you guys think. I think it could be good, but I really do want you guys' input. So please let me know. But until next time, I'm Rootinchi. Y'all have a good day. See you next time.